Welcome to Season 2 of the Battery Podcast from Siemens Digital Industries. I'm your moderator, Nick Finberg, and I'm joined by our resident host, Puneet Sinha, the Global Head of Battery Industry at Siemens Digital Industries Software. And we're here to bring you great conversations from industry experts from across the battery landscape. To kick off the new season, we have Todd Tuthill, the Vice President of Aerospace, Defense, and Marine Industries at Siemens Digital Industries Software, for a conversation around battery integrations taking flight in aerospace. Puneet, you were the one that kind of pushed to have this conversation on aerospace. Why don't you start us off?
I first want to share my excitement to be on this podcast with Todd. Not only because he's a great person and it's always fun to be on a podcast with him, is also because whenever we think of electrification of transportation system, most of the time the conversation goes to electric vehicles. Four-wheelers, two-wheelers, or the big vehicles, off-road, on-road. But there is this whole dimension of air transportation, and that is a key area where industry wants to take electrification to. And that is, in certain ways, really tough. So when we look at, from the batteries perspective, from many, many years, we always have looked at what will it take to bring electrification to air transportation. And as Todd said, air transportation comes in different flavors. Electric VTOL, air taxis that Todd talks about is a really exciting area where we are seeing the first wave of how batteries can be part of air transportation. But that is just starting point. There are many, many different dimensions. Todd mentioned drones. Of course, in the longer time horizon, there are ambitions of what will it take to electrify short to mid-range air transportation. And of course, the transatlantic, transocean is perhaps far away, but it's still on that journey. So when we look at this framework, it's not good enough to look at those systems only from batteries perspective, but also from the perspective of what Todd brings, a seasoned leader in the aerospace system. And I'm glad that our audience is going to today listen to Todd, a seasoned aerospace leader who can share, when he looks at system and battery being a part of that, what are the requirements, what in aerospace industry is looking for to bring batteries and other electrification technologies in those systems. So to me, that is key highlight of this podcast, to be listening and sharing and exchanging views with Todd.
What innovative things are happening in the aerospace industry for electric aviation and the role in battery supporting it? Todd, what are you seeing in aerospace?
There's all kinds of incredible things going on in aerospace. I'll talk about two. I'll talk about point-to-point cargo and delivery, and George Jetson's car will be the second thing I'll talk about. So let's talk about point-to-point delivery, cargo. We've kind of all seen the commercials, about these small drones delivering Amazon boxes and pizzas, and that is kind of taken off. But there's one company in particular that I want to call out. They're called Zipline Aero. And all the listeners, if you've never heard of Zipline, you got my permission. Pause the recording. Go look them up. Zipline Logistics. They are an incredible company now, flying small electric drones. And they've since 2016, they've done more than 1 million deliveries, flown more than 90 million miles, mostly in Africa. And their website says they've already sent things to more than 4,000 hospitals and health centers in Africa. And they've saved a lot of people's lives with these small electric drones that fly there and back. So point-to-point delivery is the thing. We don't see it as much in this country, but in emerging countries like Africa, where it's hard to get things places, we're starting to see those drones really make an impact. So in addition to point-to-point cargo delivery, we've also got flying cars. When I was growing up, I'll date myself, one of the cartoons I loved to watch was George Jetson. And the cool thing about George Jetson, he didn't take a car to work. He and his family took a flying car. It wasn't a car that went along the road. It flew through the air. And I always wondered, would that ever happen in my lifetime? And the cool part is it's going to happen in our lifetimes. It's going to happen by 2030. Puneet and I Puneet, we're going to fly together on one of these air taxis between now and 2030. There are a number of companies working on that. They haven't been certified yet. But by the year 2030, you're going to go to a large city. And if you want to fly from point to point and avoid traffic, if you're in LA and you land at LAX and you want to get to the beach and in South Beach without a 2-hour wait in traffic, you're going to be able to fly there in this air taxi. And just such cool things, such a cool time that we live. And I can't wait to really get into this with Puneet in this podcast and talk about all the challenges and all the cool things that lay ahead with electrified air transport.
I'm curious, Puneet, what's happening on the battery side to kind of help feed into aerospace? Are you working directly with any of the OEMs for designs, or is it just kind of they're taking stuff off the shelf?
So answer is yes, we are starting to work with some of the companies exactly on the lines of what Todd said. In the air taxi domain, there are a lot of companies, some of the ones that people are more aware of, Joby Air, Lillian, there are many such companies who are actively working in that domain. We are looking to work with them to see what are their challenges, how those challenges are different from ground transportation, and what does that mean for batteries requirement, both for design, but also safety side, also from the usage profile and durability. And all those dimensions I look forward to covering in this podcast with you and Todd.
Well, let's kick it off with one of those challenges Todd mentioned. Storage density is a big problem across battery applications. It's going to be especially so for aerospace. Every kilogram we can remove is extra distance you can fly. How is that shifting communication between aerospace OEMs and manufacturers?
Great question, Nick. As I mentioned earlier, all the batteries that we have designed, we means as industry, battery industry has been designing and manufacturing, has been predominantly looking at vehicle electrification in mind, has been and increasingly for battery energy storage systems. So either a stationary application or ground transportation. And roughly, the state-of-the-art battery energy density is close to somewhere between 250 to 300 watt-hour per kg. What does that mean is 1 kg of lithium-ion battery cell today carries around 300 watt-hour worth of energy. That is a significant improvement in the energy density in last 10 to 15 years. It has almost tripled. And that is because of all the material level breakthroughs, improvement at the cell and pack level in the design and engineering and how they are being manufactured. As great a breakthrough and advancement it has been, that number is still falls significantly short when you start looking at air transportation. The magic number in certain way that unlocks a mainstream conversation for battery power air transportation is 500 watt hour per kg. So if you look at it, almost 80% additional improvement in the energy density is required, desired to make air transportation powered by battery mainstream. And this is where the great challenge lies for battery industry to increase that energy density through material innovation, through improvement in design, while making sure that those batteries are absolutely safe. Because we cannot emphasize how critical it is to have those batteries safer for air transportation. Todd, how do you see it?
Yeah, I think you're exactly right, Puneet. That magic number of 500 is certainly true in terms of profitability. And if you think about the impact that has on not just the design of the aircraft, but the whole concept of profitability for this industry. If I look at we talked about air taxis, that's probably where we'll focus a lot of our discussion today. Most air taxis today, if you look at the weight ratio and the size, you put it all together, they've got a range of about 80 to 100 miles. That's maximum range. And that's on a good day with good weather, When you factor in bad weather and margins, it may even be a little shorter than that. So most of the industry right now in the air taxi market is being designed around that number, 80 to 100 miles, with the reality of really most of it will be point-to-point within large cities. That's where we're going to start. And it's going to take a whole lot of aircraft and a whole lot of passengers to make that profitable. When it really starts to become more profitable, and I think that 80 to 100 is really based on, from what I'm told, current day technology, the 250 to 300 number. When we start getting up to the 200, 250 mile range, now we can start talking about flying between cities, not just inside of a city, but from city to city. And that's where we'll start to see more and more profitability, because really, if you think about now, an air taxi, they're competing with Uber. And their business model is, we're going to get you faster, we're going to move you faster across a large city to not wait in traffic. And while there is certainly some utility in that, when it really starts to become a bit more profitable will be when we can build a little larger versions of these vehicles that can hold more than 4 passengers, that can hold 6 or 8 or 10, and I can fly between cities. And then we're talking about more profitability, and it's going to take that 500 to 600 kilowatt hour battery to get there. Or did you say watt hour, kilowatt hour? I think I got the units wrong, but I think you know what I meant.
Yeah.
Twice where we're at today.
Yeah.
And the other question I think you asked was, how does that affect the communications of OEMs and battery manufacturers? And what I'm seeing in aerospace, because this is such a critical thing, in some cases they're one and the same. Some of these OEMs are actually getting into the battery technology. I've talked to some of the OEMs, I won't name them, but some of them ask them about the batteries, and they're saying, which batteries are you using? And they're saying, well, our battery technology is proprietary. And they're having to really invest a lot of time and money to develop this proprietary battery technology of their own, just so they can get a leg up on their competitors. So it's a big deal, and I'm sure we'll talk more about what that means relative to this industry and the decision to go into it, and the ability to prove that you're profitable to your venture capitalists investing in your company.
You said climate and kind of the environment that you're going to be flying a route for one of these air taxis has a big impact on range. I'm curious, on a cold morning, I have to make sure that my EV is plugged in to get a better charge for commuting. Are there steps that you kind of have to take for these kind of aircraft? Are we to that point where we're thinking about infrastructure for the battery systems?
Absolutely. If I think about, again, an air taxi, I think there's a couple of options. One option would be you're going to warm the battery with it still plugged in, which of course takes time, a way that you're not making flying revenue flights. There are also some companies that are designing their air taxis with removable batteries, where they're not actually going to charge them when they land, but they're going to swap out a new battery pack, and therefore the battery pack would go in warm. Now, another thing to think about, it's not a apples-to-apples comparison of an air taxi to a commercial aircraft, because part of the reason commercial aircraft have to de-ice so often is they're flying at 35,000 feet, where it's minus 40 degrees outside. Most of these air taxis are going to fly at 4,000 feet, not 35,000 feet, where it's still cold. In a lot of places, and especially in places like the Northeast in the winter, but it's not going to be minus 40. So it's a little different, but still, that's certainly a concern that batteries have to stay.
So it's less about the exact flight safety requirements versus range implications.
There's that too. We'll probably get to flight safety, but it's not quite like flying at 35,000. If you had to fly a battery-powered aircraft at 35 or 40,000 feet, then it becomes a big deal to keep those batteries warm, and it's not going to be quite that cold at 4,000 feet. In most places, unless we're going to fly in Anchorage or something, and I don't think we're ready to put air taxis in Anchorage, Alaska yet.
So lifespan and longevity is another topic I'd like to hear from both of you about. What is the average operating life of these aircraft, and will batteries be able to maintain the charge-discharge cycles of commercial applications? Are companies looking more into repairability rather than durability?
So think about time frame for the life cycle of these aircraft. So let's talk about a typical commercial aircraft. you're talking about a lifespan of 20 to 30 years. I don't know that we'll see that out of these initial air taxis necessarily. Maybe it'll be closer to the lifespan of a car, but that's probably at least 10 years. So you're looking at anywhere from 10 to 30 years lifespan on these aircraft, and they're going to fly 7 days a week. They're going to fly from dawn till dusk, probably even after dark. They may fly 8, 10, 12, 15 times a day. So you're talking about many thousands of cycles. And certainly longevity of those batteries is a very big concern because when you think about the statistics we were quoting before, about 80 to 100 miles, that's assuming a battery that's got most of its life left. And again, I think about my cell phone and what happens to my cell phone after a couple of years. All of a sudden, my cell phone that went 2 days on a charge, now I'm wondering if it's going to make it to the end of the day. And that's not going to be acceptable for these air taxis to have the range and the safety they need. They're going to need to have 80% plus at the battery life. So I think what that's probably going to mean relative to these aircraft is that they're going to have to price into the life cycle cost of the aircraft, replacing the batteries a number of times. Unless Puneet's going to tell me about some magic technology here that I don't know about yet, that's going to suddenly make these batteries have a much longer life. I think that's just going to be part of these first wave of designs, that they're going to have multiple sets of batteries over their lifetime.
Yeah, Todd, I don't know any such magic, but I second you. So if you look back, what defines or determines life of a battery? From a very first principle basis, there are two key things that are critical to determine the life of a battery in whichever application you use, whether it's a cell phone, a car, or an air taxi. One is the temperature. What is the temperature batteries are exposed to? Right? And second is cycle, how you are cycling the battery. What is the maximum voltage you are taking to, minimum voltage you're taking to, and how many times you're going through. So it's essentially, it comes down to, in the battery language, cycling of battery, which voltage range you're taking to. And the other is, when you are not using battery, what are you doing with it? Is it all the time plugged in? Is it exposed to high temperatures, which can have some adverse effect? And those first principles, or the basic physics or electrochemistry, applies to batteries that will go in air taxis too. So let's look at it. As Todd said, if you look at eVTOL, when they are operating, they are at higher altitude, lower, and that means lower ambient temperature than what a typical car typically get exposed to, a typical electric vehicle. In an electric vehicle, you have to cool the battery down a lot more than you have to heat it up. Right? I mean, of course, in the winters, and if you're in a very cold place, you will have to heat up battery. But most of the time, it is about how you're going to cool the battery so that its temperature remains in the favorable zone for a battery, which is somewhere between 10 degrees Celsius to 35 degrees Celsius, exactly the temperature range of a human, but what keeps a human happy and efficient. That is one. And of course, how eVTOL is getting operated, those temperature ranges that eVTOL is exposed to is going to be different. It will have implications on how to cool or heat up a battery in an eVTOL. That will determine its life. Second thing is the kind of duty profiles a battery will get exposed to in an eVTOL is absolutely going to be very different than the kind of duty profiles a typical electric vehicle get exposed to. And the way I've understood, there are three key things for eVTOL. One is when it lift off, and lift off, that requires a lot of power, much higher power than what is required in an electric vehicle. Then when it is cruising, then it's a lot lower current you're drawing. But then when you're landing, again, you need to have a lot of power, and there are certain FAA regulation that it starts coming in on how much charge you need to have before you can land an eVTOL. So that means it's a much higher power requirement for a short period of time, both when you are going up in the air or when you're descending, and much higher temperature. And one of the very important thing is there is no regenerative braking. In electric vehicle, you need to account for when you're doing braking, battery should be able to accept that charge, and that starts determining how much of battery power or how much of battery voltage you can use. In eVTOL, you don't have to worry about regenerative braking, so that changes the operating window for a battery in an eVTOL compared to electric vehicle. So all of these boundary conditions, it starts impacting the voltage range battery in an eVTOL will be exposed to or should be exposed to, is thermal management, and the ambient conditions it needs to operate in. So to ensure safety as well as longevity, it comes back to, again, the materials, chemistry that can withhold those voltages and temperatures, but also at a system level, how a battery is being managed thermally through its thermal management strategy, and also how every cell voltage and current is being monitored and state of health is being monitored through its battery management system. Those fundamental things that are very critical for a success of battery in an electric vehicle or in energy storage system applies to battery in eVTOL. It's just the boundary conditions are different.
And Nick, if I could follow up and build on what Puneet says, because if you think about all those things, Nick, that Puneet talked about relative to what affects a battery, and then you look at the financial model of an air taxi and compare that to the financial model of operating an eVTOL car, the reality is most people that drive an electric car own the car. And it spends most of its life parked somewhere where it can charge for a long period of time. Then it operates, and you go to your office, you park it all day, you park it in your garage. Because you own it, no one else is driving it. That's not the case for an air taxi. When they're first released, I think, 5 years, 10 years, it'll be a long time before most of us can afford to own our own air taxi. We're going to rent them. We're going to rent time in them like we rent time in a taxi cab or pay a fare to ride a bus or a commercial aircraft, which means those things are operating all the time, which means they're either operating or they're charging. And Puneet said something really key. He said it's also the temperature that the battery is when you charge it. Well, if you think about the use case for an air taxi, we've created kind of the perfect storm. I've just landed, which is takes the most power required in the whole flight of that aircraft. Just about is landing it. So the battery's pumped out all this power. It's gotten really hot. I've unloaded the passengers, and I want to very quickly recharge. So again, unless we come up with some new laws of physics or some other way, these batteries are going to be charged hot, which is bad for these batteries, which is going to reduce the lifespan of these batteries, which again is going to make them not nearly as useful for air taxis. So it's a perfect storm. It creates some interesting engineering problems that companies have to overcome. And again, which is I think why we're seeing some of the OEMs decide to not charge the batteries inside, but to swap the batteries out. Because if you can do that, you can start to, it's a bit more expensive because you have multiple battery packs. You have that ability to not have to do the fast charge when hot. Which will certainly increase the lifespan of the batteries. It'll be interesting to see. I haven't seen the trade studies to see what's actually cheaper, just to run the batteries hot all the time and replace them all often, and not have to have where they're custom designed in the vehicle, or to add the extra weight and complexity to swap them out every time. And I suspect we'll see that change over time as battery technology and air taxi technology evolves.
One thing I also would like to add, because Todd said it a couple of times, and he's absolutely right, that it's not companies are looking at eVTOL and batteries, and they're not just as a technology, but how it needs to be operated, which is different than our personal own electric vehicles. Right? They are not going to be idle most of the time. Most of the time, they are working. So if you look at it, in our previous episodes, we have talked about buses. We have talked about battery swapping. We have talked about cell-to-pack technology. All of those dimensions get activated in this perfect storm of eVTOL, as Todd said it, because, as he said, I mean, if you look at it, battery swapping is getting a new life again. In China, there is a lot of activities happening on battery swapping, even for passenger electric cars, instead of charging them. When you look at eVTOL, perhaps there is a very different business case of why to do that rather than charging. Right? As Todd said, charging a battery hot, while it is hot, it just landed, you have to charge and be ready for another flight. So if you charge it, you have to cool the battery while you are charging, and you have to dump a lot of power in a battery to charge it quickly, because every minute eVTOL is charging, it's not making money for the operator. So does that open up new business cases and justification to swap the battery? Those are the things I know companies are looking at. But then it is not just about, hey, I'm going to swap a battery. If companies are looking to swap batteries, how you put those batteries, what kind of modularity you need to have in the battery, standardization in the form factor, where they are put it in an eVTOL, ease of removing those batteries, all of those things needs to be accounted for when the batteries are being designed and how the whole system is being designed. So all of this, companies need to look in from the very beginning. These are not something that companies may want to look at in an afterthought process, and that starts adding to the complexity.
That seems like a good place to stop this episode, but we still have more to talk about with Todd on the aerospace industry. Make sure to subscribe so you don't miss part 2 of our discussion, where we cover some of the design implications regarding safety and what the future of electrification in aerospace could become. Until then, you can check out our previous episodes of the podcast with customers and industry influencers, or read into our solutions on our website, siemens.com/battery. This podcast contains the personal views and opinions of the speakers. It is important to note that these opinions are solely those of the speakers and do not reflect the views or positions of Siemens, its management, its employees, or any entities the speakers may be affiliated with. Siemens as a company does not endorse any of these statements made in the podcast. Siemens bears no responsibility for ensuring the content's accuracy or verifying the statements made in this podcast.